So in number 3 of the test review here, we're supposed to write the first 5 terms for the following recursive formula. A sub n equals 6 times a sub n minus 1. Assume the first term, a sub 0, is 1 over 18. So we're supposed to find the first 5 terms. And the way that we're going to do that is using the recursive formula. We're going to simply take the first term and multiply it by 6. So 6 times 1/18. You can multiply that 6 to the top. That's 6/18. 6 over 18 reduces to 1/3 is the second term. The third term is going to be 1/3 times 6. So 6 divided by 3 is 2. To get the fourth term, you multiply by 6 again to get 12. And then the fifth term is 12 times 6, which is 72. So that's number 3. The next one I'm going to look at on this test review is number 7, which is expanding logarithms. And the rule to remember when you're expanding these logarithms, division signs become minus signs, and multiplication signs become addition signs. So here I'm going to take this one logarithm and I'm going to expand it into 2 logarithms. I see an x, I see a divided sign, so I'm going to make that minus. Now that y squared, I'm going to take the 2 in the exponent and move it out front, so make that 2 log y. Part B, I see a division sign, so I'm going to take this one logarithm and expand it into 2 logarithms. Log of A minus log of B. But notice that it's got an exponent of a 4. So what I should probably do is move that 4 in front of both logarithms. Because right now, these are both, that's a to the 4th, b to the 4th. So let's make that 4 log a minus 4 log b. So those two were both expanding by subtraction. These next two we're going to expand by addition, because that says 4 times t squared. And this one says q times r times s. So on this one, we're going to make it log 4 plus, because that's multiplication right there, 2 log t. You can just take the exponent and move it out front. On this one, I'm going to go ahead and move that exponent out front to start with. Make it 7 log QRS. And then expand it and distribute the 7. Let's make it 7 log Q plus, since it's multiplication, 7 log R plus 7 log S, which would be the answer to 7a. So the big takeaway from that is when you're expanding, division becomes subtraction, multiplication becomes addition. Let's talk about number 17 next, which is a solving problem. And remember, when you're solving these exponential problems, that the best thing to do before you take a logarithm of anything is take care of the pluses and minuses and take care of the coefficients. So the first thing I'm going to do is add 3 to both sides. Make it 8 times 4/9 x equals 93. And then divide both sides by 8. 4/9 x equals 93 over 8, which is 11.625. Now we want to go ahead and take the log of both sides. So make it x log 4 over 9 equals log of 11.625. Then the last step to get the x by itself is divide both sides by log of 4 over 9. X equals log 11.625 divided by log of 4/9, which is approximately, I'm just going to round this to 3 decimal places, log 11.625 divided by log 4/9. It's about negative 3.025, which was the answer to number 17. I'm going to go ahead and do number 21 next. Which is another solving problem. It's one of these application problems, though. In number 21, it says, write the time in years for $200 to double if the money is invested in an account which accrues 3% interest compounded twice per year. So, $200 doubled is $400. So I'm going to go ahead and write an equation here. 400 equals, and I'm going to use the compound interest formula, which you'll have access to during the test, so you don't need to memorize it. 200 times 1 plus the interest rate divided by 100. 3 divided by 100 is 0.03. Divided by the number of compounds per year, which they said is twice, so divide by 2, raised to the 2 times t power. And we're going to want to get that t by itself. First thing I'm going to do, divide both sides by 200 to get 2 equals, and I can evaluate the inside here, 0.03 divided by 2 plus 1, that's just 1.015, and it's all raised to the 2t power. Now to get that by itself, to get the t by itself, I should say, we're going to take the log of both sides. So we're going to do the log of 2 equals 2t times the log of 1.015. I just took that exponent and I moved it out front. That's the power of logarithms. Now I'm going to divide by log of 1.015 to get 2t. So that's going to be log 2 divided by log 1.015. So to just get the t by itself, the last thing we need to do is divide by 2. So I'm going to take everything and divide it by 2. That's the exact answer, but we want an approximate answer. How many years is it going to take? So I'm going to need to type all of that into my calculator. So I'm going to do log 2 divided by log of 1.015. I'm going to take that answer and divide it by 2. It's going to take just about 23.28 years for that to double. Now we're going to solve the same kind of problem in number 22, except this time in 22 it's compounded continuously, so that's a slightly different formula. Again, one that you don't need to memorize. One that I'll provide to you on the test. But write the time in years for $500 to double if the money is invested in an account which accrues 2.35% interest compounded continuously. So remember that equation is A equals P e to the RT. That's the formula you'll have on the test. The A is the future amount, which is 500 doubled, just 1,000, equals the initial amount, 500, times E, that interest rate divided by 100 is 0.0235 times T. And we're going to solve for that T. First thing I'm going to do, divide by 500 to get 2 equals E to the 0.0235 T power. And then what I want to do is get rid of that E, and I have to remember that the inverse of an E is a natural log. So I'm going to take the natural log of both sides. Natural log of 2. Now when I take the natural log of this side, it's going to cancel out with the E, simply leaving me with 0.0235 T. So all that remains is that exponent on the right-hand side. To get the T by itself, divide by 0.0235. T equals the natural log of 2 divided by 0.0235, which is just about, let's see here, natural log of 2 divided by 0.0235, 29.5 years. All right, I'm going to try and, I've got time to do just about one more problem, so the next one I'm going to do is number 10, which is a solving problem, kind of. Calling it a solving problem is a stretch. I'm just going to do 9 and 10 together here, because they're both pretty simple. They're just calculator work. On number 9, to get that x by itself, you need to remember that you take that base, log of 3, write it down twice. 3 equals 3, and then write the original equation up in the exponent. So the 3 and the log 3 will cancel out, leaving me with x equals 3 to the 4th power, which is just 81. And then number 10 is kind of the same problem, except we don't even have to solve anything. If you've got a fancy calculator with a log 8 base 8 button, you just type it in. Log base 8 of 32,768. I don't have a fancy calculator, so I'm just going to use the change of base formula. I'm going to do log of 32,768 divided by the log of 8. And when I type that in the calculator, x equals 5.